is the work that Val does to this ball bearing? Well, basically, we can say that she's pulling it back, and this is her applied force there, and equal and opposite force on her hand, but clearly the bearing is what we're looking at here. And so it requires her to apply force in order to pull it back because she is pulling it against the elastic. So we know that there's a force there. We also have the distance in which it's being pulled back, and we're told that as well. So what do we know from all that? Well, we know that there's an applied force, and that force is parallel with the distance that it's getting pulled. And in fact, they're in the exact same direction. So we would know that 100 newtons times 30 centimeters, which we can convert to 0.3 meters. And if we multiply that, we end up with 30 joules. All right, and we know that they're both in the same direction, that is the force and the distance. So we do know that it's a positive. And by positive, we know that that work has added energy to this ball bearing. So what kind of energy has it added? Well, because it's being pulled against that elastic, it's not in motion at the end of that pull. It's sitting there, but it's got lots of potential energy. And if you let go, that elastic would spring it out, and we'd see that potential energy come out in kinetic. But during the pull back, it's definitely a gain in potential energy.